Okay, so today we'll be doing factorization of higher order polynomials. Now, higher order polynomials are polynomials that take the form of x cubed and further up. So here we have a cubic general form, which is ax cubed plus bx squared plus cx plus d. We also have the quartic general form, which is ax to the fourth plus bx cubed plus cx squared plus dx plus e. Now we could continue to show the quintic, the quintic and the other one by just adding a higher power and more variables, but we'll just stick with these two for now. So these ones cannot be factorized like quadratics. There are special methods of factorization for them called the factor theorem, remainder theorem, and polynomial division. The factor theorem states that if x minus b is a factor, then f of b is equal to 0. So if we have a polynomial f of x and we want to see if x minus b is a factor of f of x, then we find f of b. If we have a polynomial f of x and we want to know if ax minus b is a factor, then we must find f of b over a. And if it's equal to 0, then that means that this is a factor. Let's look at an example. We want to know if x plus 1 is a factor of x cubed plus 2x squared plus 2x plus 1. So we will simply just find f of negative 1. F of negative 1 is equal to negative 1 cubed plus 2 times negative 1 squared plus 2 times negative 1 plus 1, which can be simplified to be negative 1 plus 2 minus 2 plus 1, and then this will give us 0, and therefore x plus 1 is a factor. Now, here we go for the remainder theorem. If a polynomial f of x is divided by a linear expression ax minus b, then the remainder is f of b over a. Now, the remainder theorem and factor theorem are connected in that if we test for the remainder and the remainder comes back as 0, then we know it's a factor. So they're essentially a similar theorem. Let's look at polynomial division. So here we have x cubed plus 2x squared plus 2x plus 1 divided by x plus 1. Same thing we had around the back. And we'll go ahead and just show you how to do it via polynomial division. Now, it is set out like regular division, where you have that there, then you have this inside here, plus 2x plus 1, but it can be a bit complicated, so stay with me. First, you take the x term and you divide it into the first term. So we say x into x cubed, and with that we get x squared. Then what you obtain here, you use to multiply both of these. So x squared times x gives us back x cubed, and x squared times 1 gives us back positive x squared, and then we subtract. So it's essentially long division that we're doing here. X cubed minus x cubed gives us 0. 2x squared minus positive x squared gives us x squared. And then we go ahead and bring down this term and we do it all over again. So we say x into x squared, which would give us positive x, and then we say x times x gives us x squared, and x times 1 gives us x. Then we subtract. This would give us back 0 plus x. Then we bring this down and we go again and say x into x goes 1 times x equals x. 1 times 1 equals 1. And then of course this brings down to 0, which as we tested before, the remainder of it is 0 because it's a factor. X plus 1 is a factor of this. There you have it, polynomial division. Now let's try some questions on the factorization process. First one, factorize x cubed plus 2x squared minus x minus 2. Now, in order to use the factor theorem, remainder theorem, and polynomial division, we have to guess a factor first. Guess a number that we think is, we guess a linear form that we think may be a factor, and test it using the factor theorem. So, in order to make a proper guess, what we need to do is to look at the C term. All the constants within the three factors must multiply to give you back the C term. So since we have negative 2, we know that in order to have three numbers to multiply to give you 2, they have to be 2, 1, and 1. Which means that possible factors could be x minus 1, x plus 1, x minus 2, and x plus 2. Okay, so let's go ahead and try any one of these first. And I think we'll start with x plus 1. I usually prefer to start with x plus 1. So we say if x plus 1 is a factor, then f of negative 1 should equal to 0. You can go ahead and try that. So negative 1 all cubed plus 2 times negative 1 squared minus negative 1 minus 2. Simplifying this, we would get negative 1 plus 2 plus 1 minus 2, and simplifying this, we have 1 minus 1 and 2 minus 2, so it will be 0. Therefore, we know that x plus 1 is a factor. Now, from here, we can guess the other two factors and use the factor theorem to prove them, or we can use polynomial division to get this as a product of the linear and the quadratic, and then factorize the quadratic like how we normally do. So let's go ahead and do that method. We have x plus 1 here, x cubed plus 2x squared minus x minus 2. So x into x cubed goes x squared times x squared times x goes x cubed times minus x squared times 1 goes x squared times, and so x cubed minus x cubed gives you 0. 2x squared minus x squared gives you x squared. Then you bring down the x into x squared goes positive x times the x gives you x squared. X times 1 gives you positive x, and we subtract. So x squared minus x squared is 0, and negative x minus x gives you negative 2x minus 2. X into negative 2x gives you negative 2, and negative 2 times x gives you negative 2x. Negative 2 times 1 gives you negative 2. Therefore, 0 here, 0 here in our subtraction. And based on 0, we have confirmed that x plus 1 is indeed a factor. Give me a moment. So, now that we have this, we can express the cubic as x plus 1 times the quadratic we had previously gotten, which is x squared plus x minus 2. So now that we have this, we can go ahead and factorize a quadratic and to obtain other two factors. So from our quadratic factorization, we should remember that we look for the AC term, which in this case is negative 2, and then we look for two numbers that can multiply to give us negative 2 and can add to give us 1, and those numbers should be positive 2 and negative 1. So we write this as x squared plus 2x minus x minus 2, and we group and factorize. So here we'll have x into x plus 2, then here we can have negative 1 into x plus 2, and therefore we know that this becomes x minus 1 into x plus 2. So we know that the factors of this equation are x plus 1 into x minus 1 into x plus 2.